So hi everyone, good morning. Thank you for taking the time to be here to watch Dr. Nishata Royan's presentation, seminar, and Associate Professor Julia Mendes' seminar. They are here, they are visiting UOW as part of REN's initiative. And yeah, we are very excited about the visit. I think it's been very productive, and I hope you all enjoy the seminars. Thank you.
Okay, hi everyone. Good morning. Good morning, everyone from who's there online as well. Okay, I'm Nisha here from UOW Malaysia, and I'm very happy and feeling blessed to be here today under the initiative of REN. So thank you so much to REN for giving me the opportunity to come all the way from Malaysia to present my research work and also to maybe sustain for future collaboration with UOW Australia. All right, so today I'm going to talk about my topic, which is innovating sustainable composites with reinforced natural fibers for greener future. So I'm always playing with green materials. Basically, I'm a material person. All right. So before I begin, let me introduce my colleagues back in Malaysia. So greetings from School of Engineering, UOW Malaysia. So we are reporting directly to our DVC Academy, Prof. Hon, and then we have a head of school, Dr. Yip, and then we have our two academic department head. We have three programs there, mechanical, electrical, electronics, and mechatronic, also foundation in engineering. And those are all my colleagues over there, all bunch of happy faces. All right. So we also have some research clusters in School of Engineering, SOE there is School of Engineering. So the group here, we have broken into 5 different clusters: advanced materials and manufacturing technology, applied electronics, embedded system. Okay, some of them are like interrelated to each other. Okay, we have engineering education, quality, technology management. We have sustainable energy power systems where they look into renewable energies and so on. We have our advanced control robotic intelligence system. All the lecturers that are actually working on few projects. So whoever that is interested, we can actually talk on the collaboration, or you guys can go and visit them in our website. All right, so what do I do? So basically, what do? I convert the waste to wealth. All right. So you guys are having water bottles, right? Okay, this is a very bad example. This water bottle here is made of plastics. And I take that plastics, I mix with agricultural waste, which is also a waste, and I make money from that. Of course, I'm in the initial stage here where we actually doing the research to come out with the product. Of course, not at that, but that is the aim or the direction of my project. So, oops.
You have to point to the computer. Or to, no.
Your computer.
Your computer. No?
Sorry. Okay. Okay. Sorry. So this is what I do actually. So I convert waste to wealth. So there is few ongoing projects under me. So if you guys see, I can't cover everything today. So I'm going to cover only one of the project. But all my projects are related to natural fiber reinforced composites. right? So I'm going to talk about the first project here, which is development of reinforced natural fiber composite as a feeder for additive manufacturing application. So as you guys see, the title is so lengthy. So what do I actually do here? Let me summarize here. What I actually do, I play with natural fiber composites. Using natural composites, I develop a feeder, okay, the filament feeder, in additive manufacturing application. That means I 3D print from the filament that I produce from natural fiber composites. All right, so this is the interlink. So why do I do this? How do I do this? And what is the outcome? So why do I do this will be covered there, and how is basically what is the methodology and my results. So let's talk about why first. Why this project? Why did I choose additive manufacturing? Why did I choose this matrix filler, RHDPE? Why rice husk? So why this project? Okay, as you guys know, how bad is the plastic pollution right now currently? So we can see from the statistic 8.3 billion tons of plastic produced since 1950. And from this chart, we can actually know from the year 2000, more than half of the plastics ever produced. If we put this into statistic, each one of us, we have 8 billion people in Earth now, right? So each one of us produce 625 kg of plastic waste during the entire life, which is equivalent to 12 times of my weight, I guess. Just imagine how much plastics that we are consuming and producing every day. So what should we do? What is the solution? Of course, to come out with a green, sustainable earth, and so on. So this is a solution so that we can meet our current generation, and also we can save up for our future generation. If not, our future generation will not know what is plants, what is natural resources. They will not be able to know all that. So why did I choose natural fiber reinforced composite? What is this natural fiber reinforced composite? So basically, what is natural fiber reinforced composite? I take certain fibers, natural fibers. We have kanaf, we have jute, we have rice husk, we have so many things. I mix with little bit of plastic. Okay, it can be biodegradable plastic, it can be recyclable plastic, and I come out with composite, meaning I make more plastic from less plastic. Composites are actually on par with the plastics now. So if I can make something cheaper, something better strength, so why not? All right. Why did I choose additive manufacturing? Of course, we all know here, if we want to produce something, we need to have a mold. In order to do a mold, we consume a lot of costs. So let's say we want to test out something, but we just want to do it for the testing, for a pilot research. We can't be like coming out with a mold and then doing the process and so on. So additive manufacturing will simplify our work. You just imagine, I want a pencil, for example. I want a pencil with this specific design. I can't be like going through the whole process to create the mold just to come out one pencil. And there is some mistake in that pencil's design. So we have to do back all over again. So in this case, if I have additive manufacturing, then I can straight away print whatever design I like, and that's it. So of course, for the conventional method is high cost. For the additive manufacturing is lower cost. So why RHDPE? So recycled high density polyethylene. So it's strong. From the name itself is strong. It's very durable. Okay, it's very economical. It's cheap. It's highly recyclable. So these are the main reasons why I choose RHDPE as my matrix filler, and why rice husk. So rice husk, from all the natural fibers, rice husk is the cheapest in Malaysia, right? And we have a very low density with a very good lignin cellulose content. So that's why we choose rice husk for this study, and also is waste, is agricultural waste. We have a lot of waste in Malaysia and also in Southeast Asia. So what is the problem statement here? Okay, the problem statement in this specific research is we have very limited literature because we are starting out to produce filament which no one have done with this combination of material before. We have issues with HDPE, the polymer itself, in FDM. FDM is fused deposit modeling in 3D printing. where the characteristic of the polymer itself, it has shrinkage problem, warpage problem, and so on. Limited info of natural fiber reinforced composite in FPM. Okay, as I said, this is a new research, and also limited info on filament production. So filament, nowadays we have a very big companies offering filament production, but that is for conventional filament like PLA, PETG, and so on. But a mixture of these now, yes, they are doing PLA wood, but they will not allow us to customize our filament with our material. So this project is actually to solve that problem. So there is few objectives here. I study, I design the filament line, I 3D print and evaluate, and then I produce with the composite. So this is the overall flow plan here. So I mix, compounding, I crush, I put into a filament extruder, come out with a filament, 3D print, and specimen. It seems to be very easy here, right? But the challenge here is the compounding first stage. You have to make sure they are compatible to each other. We can't just take A and B mixed together. So we need a coupling agent, we need a proper proportion, how to make, it's just like cooking, right? When you cook a rice or fried rice, you can't just, put everything together. You have to make sure there's sufficient salt and sufficient spices and all that to make it more tasty. And then we go to the filament extruder. Okay, so this is where the novelty of this whole project, where we actually customize our filament system. And then we 3D print it and so on. So filament production line, we have few stages here. We have the sizing, cooling, pulling, and spooling. So all these have been designed and customized. We actually fabricated by ourselves in our School of Engineering back in Malaysia. So sizing, cooling, pulling, spooling, and we actually produced them. We fabricated them. Some was using a conventional CNC process, and some was 3D printed. And once we have done all this, okay, so this one, the first picture here, is to make sure the filament size is we get 1.75 mm, because if we get higher than that, then it will not go into the filament extruder. And this cooling, to make sure it has sufficient cooling so that it don't swell, it don't shrink. And for that pulling, to make sure there is a tension there, so we will get a very nice filament. And spooling is to spool up the system, the whole filament there. So this is the overall filament extrusion system that we have fabricated there. So we actually, as I said, this is the initial state of research. So whatever fund that we have utilized it. Of course, there is a lot of gaps and room of improvement to be done here. With this system, we are able to come out with the filament. If you can see there, the two pictures there, the white one is pure RHDPE. So we mix RHDPE, we go through the system and we got the filament. And the below picture is rice husk. If I'm not mistaken, there's 10% weight of rice husk composition in it. So then we have successfully 3D print it. If you can see these two pictures, we have successfully 3D print it with our normal printer. As I mentioned, due to the cost, we can do better than this with sufficient funds. So I'm working on that to actually find some source of funding, some collaboration, so that we can work together for this project. Okay, we have also done some printability testing. So we, of course, this is the first time we are doing. We are not expecting perfect 100%. All right, so there is some things that we have achieved. There is something we have not achieved, where there is a gaps there, research gaps, where we are improving that currently. So here we can see we have achieved the overhang there. We have achieved the rounded shape. We have not achieved the stringing, okay, half free, and then we couldn't get the sharp edge. And the bridge was halfway, we couldn't get that part too. So of course, going back again to the compounding process, going back again to the filament process. So this is the stringing that we didn't get. We got it halfway there, but it didn't join. All right, so this is the sample that we have successfully 3D print. It's not easy. Okay, we have done that. I can't remember, a few years, I think 1.5 years my students was working on it. So, but we managed to print it. It can be done. It just needs some improvement. So if you can see that the up picture is the pure RHDPE. And as mentioned earlier in the problem statement, pure RHDPE, it has warping shrinkage issue. And it does not stick to the bed of the printer. It does not stick to anything by itself. So we had a very hard time to actually make it stick or print RHDPE. So we need to do certain rafting, certain setting, and so on. So if you can see there is some warping there at that corner there. And this is a rice husk composite. We have successfully printed, but there is a lot of voids and gaps on the specimen itself. So this is all the printed samples. So the warping is very, very bad. You can see the warping is super bad, compression, tensile. So from here, we can actually say that, yes, it is printable, it is feasible, but there is a lot of room for improvement. So these are all the mechanical properties. I'm not going to go in detail there. Right, these are the mechanical properties. So from here, we have for A, B, C, D. Here is for different weight rice husk composition. And then we have their tensile properties, we have compression properties, and impact properties. So this is the outcome. We managed to compound, we managed to come up with a filament, and we managed to 3D print. So we have successfully printed the specimen, but of course with a lot of room of improvements need to be done. So why are we doing all these projects? So we can actually apply it in the automotive industry, where we can just customize with a sustainable material. So let's say your armrest in your car, you want it in such a design. So we can just come out with a design and print it for you with a sustainable material, with a cheaper cost and a lighter weight. And of course, when a lighter part, you save on the weight and you save on the consumption as well. So everything goes back there. So this is also other applications. LED bulb body with rice husk composite. That is an actual picture being done, taken by with the collaboration with the industry that I'm working with for this project. So they made it using rice husk. Of course, they have not 3D printed that, but we are working on the project as well. And also 3D printed wood fiber. We are also looking on that. This is what we have tried ongoing. We have tried to, I've seen the cafe around here, everyone is using wood, right? I say, assume wood. So why not we substitute? Yeah, it's over there. Why not we just substitute the wood with some sort of natural fiber composite rice husk? Because wood, we still have to get the timber. And the timber, we still get it from the forest. So we are actually going to deforestation. So all the, when I visited SBRC, everything was in timber. So maybe we can work on something where we can, put in composite rice husk material to replace timber. That's what we are working on. So these are the future recommendations. So you see there's a lot of gaps in this research, but we are working on it. And these are all the achievements we have published. It's also a collaboration with Temasek, is the industry that I was talking about. University Kebangsaan Malaysia, the National University of Malaysia, and we have published a Q1 paper. We have sent for a patent filing. We have already filed a patent, and 2 more publications in progress, which will be done in 2-3 months' time. And of course, I'm also looking for potential grant application for this project, because trust me, this project has great future. All right, and that's it. I would like to acknowledge WREN for being here today physically, present my work. Of course, UOW Malaysia. I think my boss is right there. Dr. Kim is there. Okay. All right. Yeah, he's my head of school. And thank you to the team. Okay, this is not only my project, this is a teamwork from all of us. Thank you. Questions? Yes.
I have a question. Have you ever assessed the thermal conductivity of your composite? I say that because rice husk and polymers being like amorphous materials, they are likely to have really low thermal conductivity, and you being able to print them whatever you like, you can create like insulation boards and things like this, maximizing air, maximizing gaps, efficiency, thermal efficiency. So maybe this is something that you want to add.
Sure. I've not done that yet because now we are just focusing on the physical and the mechanical part. But that is a great idea where I will take into my consideration because yes, one of the application of this product is as an insulator, especially as the roofing insulator. Yes, I'll definitely take that. Thanks.
If our grant works, if the grant that I'm applying for works, and we get the equipment, we can send it to Brazil and we'll do the test there.
So we will ship it to Brazil and we'll get the test done. Great.
How much is the shipping gonna be? Expensive.
One question.
Yes.
Can you also use soft plastics
Soft plastics such as?
like this?
Plastic bag. Replace
Plastic
soft
bags.
plastic with your.
That is thermoplastic, right?
Yeah.
Yes. So what we do is actually we take the plastic, we granulate it into pellet form, and then
Plastics are generally divided into soft and hard. You mentioned the bottled one, so that is hard. That can be dissected, but this one,
okay. So
that's also a big problem. Soft plastics we use every day in bread and food and packaging, everything.
okay, I've not heard about that.
Just idea.
Yeah, just an idea. But plastics, eventually we can actually come up with a process where we actually for this project, yes, we can use. It's just that we have not ventured into soft plastics yet. But if you see chemically, yes, it's possible. Yeah, it's possible.
But I'm assuming that not every soft plastic, because different soft plastic waste, they are composed of different things.
Are you talking about biodegradable plastics?
No, just plain soft. But she's right. They also have some chemical transformation.
Like food packaging, perhaps those. Yeah, you might.
So maybe I will consider it.
Yeah, those are a big issue.
It's a growing issue.
Yeah.
And largely ignored because when we talk about plastic, it directly we think about the hard ones, but the soft ones are gradually piling up and causing climate change.
Yeah, I will put that in my mind.
Thank you.
Thank you so much for that. Yes, Grace.
Sorry. I was wondering, like, what kind of a trade-off did you have to do? Because I imagine that you're looking at having to combine different things to be able to 3D print it in the first place. So you've got to have some sort of ductility and the right kind of thermo settings and things like that. But what kind of trade-off do you then have in terms of the mechanical properties of the product?
Okay, so here we are looking into two things. One is the filament itself. Second is the 3D printed itself. Yeah. So we have two characterization need to be done. So for the filament itself, there is certain standards that needs to be followed. The ductility. Yeah. So there is a standard that we make sure that all the composition we are doing there, it's within that range. Yeah. So once the filament part is settled, then we 3D print. So 3D print also we need to optimize to get the best mechanical properties. We have to check the heater, we have to check the speed, and also other we have to do certain optimization, which I said there's a future things that is in my mind, but we are looking for a fund. So I hope my collaboration with Aziz, Dr. Aziz the other day will come through so that we can sort that out, because he's doing similar, but he's coming up with that technology where my material can, we can sell, we can send or ship my material to do the testing or printing here.
Cool.
Yeah.
Yes.
I'm just wondering because in your trial, it failed to print out the exact shape that you planned for. I was just wondering, was that because of the material or was that because of the resolution of the 3D printing because you use the material extrusion technique?
I will say because of the filament and the 3D printer.
Yeah.
Because while we were doing this project,
Yeah.
okay, we couldn't get our 3D printer with high temperature during that time. So we got it after that. So this printed picture here, you
Yeah.
saw it with the very, very normal printer.
Yeah.
So that's why we didn't get a very smooth surface.
Yes, I can
And
see that.
optimization have not been done. So currently some of our work is on the optimization process on the 3D print itself so that we get a very nice smooth surface.
I was also wondering, like, can you use like other 3D methods, 3D printing methods, not material extrusions, for
Yeah.
example, like either jetting or something like that?
Can,
Yeah.
but FDM is the cheapest.
Yeah,
And
sure.
it's very common, very
Yes.
common that we can play around. No? But other printers, we have certain limitation.
Yeah.
It's also in my plan where I'm I have a lot of plans. You know, when I talk to Aziz, I get very excited. He actually come up with something. I mean, even it's in my plan lah. We just put in all our material and it just printed out. So we don't have to come up with
Yes,
filament
yes.
actually.
Yeah.
So that is future plans.
Yeah. And also, I noticed that with the increasing amount of
Rice husk.
rice husk, and then almost all of the mechanical properties
Yes.
kind of decline.
Because of the agglomeration happen there. So when we increase the fiber, it becomes more brittle because less plastic. Plastic is ductile. Fibers make it more brittle. So that's why we can see a lot of voids in the picture just now, which cause the mechanical property to drop.
Yeah.
So what we can do here, we have to add more additives, more processing aid to make sure that the compounding process is stable. So right now, the compounding process is okay for a conventional method, but not for a 3D printing method. So there's a lot of gaps in the compounding itself so that we can get a very high filler loading because high filler loading, less plastic and more cheaper.
Yeah.
So our ultimate aim is definitely to reduce the cost. Interesting, yeah.
Could you use the UW Industry 4.0 printer?
The other day I went, she have a carbon fiber, but she said she have not tried with the composite material. Everyone is scared because it's super expensive if the material clogs there. And that's it. But that's why we want to make sure that it really works, it's okay, and then only we want to like, okay, let's try with this printer, let's try with this printer. So that's why we are trying a basic with FDM technique. That's all. All right, thank you so much. Thank you so much.
There's some Brazilian goodies here. You have to try. Yeah. This is dulce de leche, but yeah, Brazil.
Just the yellow thing has peanuts in it.
Yes, this one is also really good. And of course, can. This one, yes, but not the paçoquinha. No, this is just peanut and sugar. Very sweet though.
Everything is there.
We add a lot of sugar in Brazil to everything.
That's why it's so good.
Why are you guys so? I'll see.
You're saying
Push it out.
All right. So.
Okay, I feel
So good morning, everyone. Thank you for being here today. Also, thanks, Ren, for me being here today. Really nice to be here, and I've been learning a lot throughout this week. So today I'm gonna talk a little bit. I chose a broader subject in which I'm going to sprinkle my research here and there, but I think it's going to be, I think, useful for everyone who works in AI applications, and maybe we can also have a chat and some discussion, some inputs as well. So this study was inspired by a conference. I was at the conference. Once upon a time, I was at the conference. We had a room full of people, AI session, and this guy comes and he's presenting his amazing model to predict if from their dermoscopies pictures, if a melanoma, which is a dot, is benign or malignant. So you can have like early diagnosis and treat it. And so the guy's presenting his jobs, his model got it really well, the separation, great results, great accuracy. And this is a Brazilian conference, mind you. And at the end he said, oh, we're gonna save lives, get into hospitals and so on. And at the end of the talk, I raised my hand and say, hi, I noticed your pictures, you only showed like white people's skin. You know that Brazil has half the population black. Have you calibrated for this? Have you taken into account? And the guy goes, like blue screen completely. No one at any time in his research had asked themselves that. And I wonder what type of group are you working with that no one has like the slightest sense of diversity to get something like this done early on. So it was like embarrassing for everyone there. So we move on. Next case study is the tale. This is my tale now. It's once upon a time. I was doing my first research involving machine learning, and I chose to deal with concrete because it was a demand we had in our lab. We work with non-conventional concrete, like slag concrete, fiber concrete, graphene oxide, and so on. And we cannot use the same methods for mix design on the non-conventional concrete as we do in the conventional concrete. So we think we have like this tool who does really difficult calculations involving anything. Let's apply this to our research. So before starting with the non-conventional concrete, we try to understand how it operates in a conventional concrete. We got a set of 1,000 concrete mix designs. They come with cement consumption, water consumption, aggregate consumption, and it delivers the compressive strength of the concrete, what we usually aim for. I'm a civil engineer. We used like our models, these data set, 1,000 concretes, like from a Taiwanese researcher, and we were comparing to the literature. We had people like doing amazing models with 0.89 determination coefficient, 0.93. We got like 0.82, but we used like a really small fraction of it. So it was great results, and I go, congrats, let's publish it. And then we had like another set of concrete mixtures laying around for different work. So I said, we've trained our model with this concrete that we got from this Taiwanese researcher. Why not test it with this other data set that we have from all over the world? So we trained with about 400 mixture designs, and we tested with 339 other mix designs, and we got 0.42, and I'm like, what is happening here? Why our results got so low, especially compared to the literature? Everybody was getting 8.85, 9.95, and so on. So we tried to dig out what was happening in the data set, and we found out that the data set was assembled in the Southeast Asian and Eastern Asian about this researcher with concrete from 87 to 97, and we know what concrete technology will grow from there. And aggregates, really small aggregates, so it was nothing to do like what people usually do nowadays. So it's not like our model was bad, it was not representative of reality. So so now we published it. We use this argument and published. So we were talking about what's happening there. Are these things still happening everywhere else in the world? And it's because we tend to think sometimes that algorithms, or the models generated by them, they are like fair, they are unbiased, they are impartial because they use mathematics and statistics and really, really hard stuff. But it's not, it's not purely objective, because even though the calculations might be impartial, the AI is about data, and not all data is unbiased. So if you have the data with gender, race, or any other type of unbalancing, the algorithm will perpetuate those biases. And a good example of this happened with Amazon in 2018. It was like a really polemic. They used a machine learning algorithm to pre-select resumes of applicants. And they used to train this algorithm their own database of developers, which were mostly men. So to no one's surprise now, the algorithm only picked men to work on that selection process. So based on these stories and the things that we've been seeing around, like doing in our labs, being published, my team and I, we came up with a seminar and came up with the 7 sins of AI algorithms. So buckle up. The first one being inconclusive evidence and unjustified actions. So decision algorithms, data mining, they establish patterns, they establish correlations. However, not every correlation has a cause and effect relationship, and this can lead to unjustified actions. So here's the case of a German company for credit risk assessment of people, and they were assessing the risk of default of their base of clients, and the company was classifying as negative if one person wanted to know their own score. If you join the database, I want to know my score, I want to know my risk assessment, they say, oh, this is a negative evidence, so like your score goes down. And so because the company was penalizing consumers for exercising their own rights to know their data, so after that, Germany passed a law to prohibit this kind of practice. Second thing here, incomprehensive evidence and opacity. Most machine learning algorithms are what we call black boxes. You know the input, you know the output, you don't know what's happening in between. This is really stressful, this is really important if we're talking about things that deal with human lives. And when you're applying to concrete, and you're applying to structural engineering, when you're applying to robotics, when you're applying, for example, automation, autonomous cars are really a big example of that. There's been like some fatal accidents, but we don't know how the algorithm operates, so we don't know why the accident happened. How can it be? It can be fought. So every one of us who deal in engineering and STEM, we have lives depending on us. We should have more transparency of what is happening inside our models that we're publishing and say that we're going to save the world and so on. The third thing is misguided evidence and biases, because the quality of the automated decisions that the algorithms take is based on the quality of the data that they process. So when we train, for example, the Amazon hiring case, when we are building models with Taiwan based database, it doesn't mean that the algorithms are inherently bad, but we must recognize the conditions, the limitations of what we are developing, of what we are proposing. Otherwise, we can be we are very faulty with our ethics of work. So number 4, unfair results and discrimination. Here we have like a concept difference, the difference between bias and discrimination. Bias is a dimension of decision making. Discrimination is the effects of this biased decision that affects people, especially disproportionately. So, for example, the melanoma model, it could prevent people of color to getting early access to treatment because it was wrong. Imagine if it were implemented in a real hospital. Also, we've been around and we're visiting the lab, and some of the labs that we visit in the Industry 4.0 hub, they were only designed to right-hand people. So like, hey, I won't get enough training. My training is not so good. because I'm left-handed and so on. I'm here stopping a little bit to be more focused on the number 5, which is negligence, basically negligence, because it's the one that we've been seeing a lot in our practice nowadays. So the first item of negligence is the poor quality data that I've seen, so like mentioned numbers as an example so far. So we have insufficient data, unbalanced data, like some categories much more than others, incomplete data, outliers. So we have to analyze our data before developing the model and take the measures necessary to correct them. For example, getting more derma photos from other types of people around the world would be an option. We also deal with overfitting, which is when the algorithms train so particularly to a certain model that it memorizes this model, and instead of it cannot be generalized to other types of concrete. Example, the Taiwanese example of concrete. We have underfitting as well. This is when our model cannot accurately represent any correlation, any pattern. It's just like the model is not adjusted to the data, and you can have several tools, several strategies to improve your performance. But then most of the times we usually go falling into overfitting because it's easy. Everybody wants to have to see like great data. We think you can only publish if you have an R2 above 0.09 and so on. So like this is poor science being done. We also have something called data leakage. We think of data leakage as in privacy concerns, but here I'm talking about some of your data, some of your inputs from the testing data set going to the training data set. And here we have a picture of a case. Once upon a time, there was a PhD student in Brazil, and he was doing this awesome model to detect damage from rails. They would install a camera in the front of the train. The camera would take pictures, and the pictures would see like if there's any damage to the rails. Okay, awesome idea. So like deep learning, great results. They would then detect several types of damages. The determination coefficient was like 0.98, 0.99. They were like, congrats, hands shaken, pats on the back, you're awesome. And the PhD, he defended with merit and honor and so on. A couple months later, a second PhD started to work on the same project to develop some more applications. And his R2 was like 0.5, 0.6, what's going on? And they found out that the first PhD student was actually using some images from the training to the testing.
Oh.
We don't know yet if it was on purpose or just negligence, sheer negligence. But this is definitely leakage, and it shall never occur. But because it's such a basic, such an obvious mistake, no one thought about looking into it. Again, everybody was so impressed by great results that we sometimes forget to overlook important stuff. We also have poor selection of evaluation metrics. There are many evaluation metrics for regressions, for classifications, and this is just an example. I have a student, a master student, who is doing modeling for pricing of apartments, houses, real estate in our city. And before jumping to his own model, he was doing a research review, a literature review, and he got 61 previous works, and 8 different metrics were used. Like they didn't even get to a third. Like what are everyone doing? Like how are you measuring? How are you choosing the selection metrics? And the selection, these metrics, they depend on what information you want to get from it. What's the type of the model that you're using, and what's the data set looks like, because you can get false positives, you can have false negatives from it as well. So you cannot just use what other people have been using. You have to study the metrics that we are applying. The one before last, which is autonomy and privacy, also a thing. We know that nowadays we have social media and those personalized algorithms for everything, and there's like a really fine line between helping people, aiding people, and controlling our decisions. And if what we see can be manipulated, who has the autonomy to make their own decisions. And also at home, we've got like smartwatches, we got smartphones, we got those Amazon Alexa and so on. And so raise your hand if it never occurred to you, like you're talking about to a friend about something, and about a few hours later it pops up in Google Ads. Come on, we know we're watching. And it's also something that we have to keep on track. Sometimes like we can be developing a sensor or something that's recording people without even we acknowledging. It's not made for harm. It's just we have to pay attention to this stuff. And finally, traceability and moral responsibility. Because back in the day, when we had to code line by line, everybody knew what their algorithm were doing. We could explain to anyone. Now with IA, especially in unsupervised learning and so on, we don't have like accountability in the same way, because if we cannot control, we cannot see what the algorithm are doing, or we cannot control their processes. Who is responsible for their decisions? Like in the case of the fatal accidents of the cars, who's responsible for it? Developers, the company who's building it, the programmers. Like there's no consensus right now, and because we're living in such a gray area, it's also dangerous for us who are working with these technologies. Everybody seems to think there's like a consensus that in the future we'll probably have like auditing to make sure that these algorithms they follow the laws, the norms, and even cultural aspects of the society that's developing them. So to conclude today, what after all these like horror stories, what can we do to not be an example in my future lecture? So first one is to use a human-centered design approach. This is like most important, basic stuff. Always think about the people who are using, not getting good results. Second, understand the limitations of our data set and our model. And third, when possible, look directly at the raw data. Like we have to understand our input data as much as possible, because from what we've seen is completely directly to the results we are getting from it. So how can we design fair algorithms? First of all, design the model to be unbiased. And to do this, we need an interdisciplinary team. We need people with different backgrounds, genders, race, ages, and also disciplines as well. Like we need input from social sciences, because they're all from STEM. We tend to think like really related to our own bubbles and so on. We have to check for unfair biases, which is to organize a diverse data set and do not start until your project, until you know you're fully safe and comfortable with the data set that you have. And also always encourage user feedback and make sure that the users that are testing our model are from multiple backgrounds. They are real world applications, real world people. And finally, design the model to be interpretable. Nowadays, there are lots of tools that are being developed as we speak to try to open up those black boxes and try to understand what types of calculations the algorithm are doing. There are some models that are much more transparent than others, and we can also try to select the ones that are more transparent. For example, decision trees that are much more transparent than other types of models of machine learning. And finally, keep learning because there's like a big chance that in 5 or 10 years from now, everything I've said will be useless, will be evolved, will be dealing with new problems, because this area is evolving so fast. And we have people from all modules, all backgrounds jumping in, which is a great thing, because now we have more applications and more different people working, but it's also a bad thing, because if you're just jumping in without strapping your seatbelt on, knowing how to drive, we're probably going to make one of those sins that were previously explained today. And one important thing that we should all have in mind is that these problems, they will not go away with just technological thinking, that it has to involve social, cultural, legal, and political aspects as well, because social responsibility and development, technology development, they have to go hand in hand. Okay, so this is what I have to tell you today. Thank you again, everybody, for being here. Let me just present you really quickly my research team. It's called CIDENG, which is a research group of data science applied to engineering, and we have people from all backgrounds. We do structural, geotechnical applications. My case is like civil construction applications, and so on. So it's good to have like people to talk to, and then we are also available if anyone wants to join in and talk about it. I'm also always an enthusiast. So that's it. Thank you.
Any questions?
So now the next stage. Oh, sorry.
I do have a question.
You're good.
I'm not sure if you would know, but so data labeling is obviously a big part. It's something that we should be concerned if we don't want to have biased models in AI models. And I was wondering, in that problem with skin cancer, if you know who labeled the data, were them experts or like doctors? Do you know?
I think it came from a data set, American data set. That's why there were so many white people. Because there's also the case like some algorithms from health insurances, they exclude black people because people of color in general, especially in the United States, who has all these data sets, they don't have much access for non-white people. So it was because of that. It was from the medical data set from the United States.
Okay.
Okay, hi Julia. This is not in my field, but just nowadays there is ChatGPT and so on, and it's also in AI field, right? So how you guys as a researcher or who's working on the project overcome this? Is it like is it a threat to you guys, ChatGPT?
Yes, I use ChatGPT sometimes, not gonna lie. I think it's a tool that you can use for better or for worse, but I don't understand what's the question.
I mean, will it like overcome a researcher? They don't go like you were talking about ethics, right? So some
I
algorithms
see.
can be you can use ChatGPT to get it. Some data you can get it from there.
Mhm.
So I know ChatGPT is an assistant to help us a bit, but how if researchers misuse this ChatGPT? That will it be a threat to the whole STEM?
I kind of think I see your point. Those ethics issues that we've talked about here, they're more related to the results and outcomes of the model, because there's a whole lot of social issues as well, like taking jobs and so on. As we stand today, I don't think those tools they can overcome us, because they are not yet very ready to think new things. And what we do basically as researchers is get new things done. We got the creativity, we got the innovation, and as we stand right now, these models they just work with data from the past. So the amount of creativity that they have is really limited to none. They can only correlate things that already exist. So right now, I think creative people are maybe for the moment on safe, but I cannot speak for 5 years from now. Yeah.
Okay, thanks.
Professor, could you recommend any checklist, or is there any set of standards or checklist or principles for machine learning AI practitioners while designing the algorithms that we discussed? Like any practical tool?
I've had like some great references here. These one like being the most important of them. If you give me your email later, I can give you the link. But
Can I take the picture?
yeah. But yeah, so right now it's a lot decentralized. There's no one that I've seen. There's no one guideline or one best practice movement, and even laws. They are just starting
Still
to.
developing.
Yeah. So we are like on the very more dangerous position right now because we are touching soil that has not been tested yet. And our mistakes will be inspiring the next level of papers talking about ethics. So like we should keep those in mind. I think this is the best we can do.
So there is an ISO standard on ethics in AI, but it's very, very high level. So I don't think it's not practical as a
Yeah.
guideline. But I was just thinking, like, going back to the example with Taiwan and how, it's going to take researchers a lot of time to go back to the base data on every single piece of research they do. So is there a case for standardizing transparency or having a minimum number of things that every published paper in AI has to adhere to make it easier for other researchers to not have to almost replicate their research to make sure it was right?
I agree with you. I start from that as well.
Yes.
So if you would like, we can do like a group thinking, brainstorm, and that's why we start for sure.
If I can say, I really appreciated, I don't know if you cheated someone, when you said the data are biased. I mean, this may be the huge problem that we have, especially for the application, because people that used to develop algorithms, they think just about the mathematical aspect, but the ethics maybe is more related to application, no? And yeah, I mean, the problem could be solved once the people start to learn really and study really about this kind of stuff, because maybe there are very heaps of people that try to join in this sector just without know anything about it. So they keep the data. They also, often the people are not neglecting. I mean, just because they forgot to do stuff, but they did it because it's better publish stuff with high performance stuff. But I mean, I really appreciated your presentation. It's inspiring me also for my students in Italy. In fact, I'm going to ask you if you can share with me the slide, because the topic is really, really important. And I know it also because I come from, I don't know if you know, from autonomous driving sector. Before to join in research community, I used to work for autonomous driving company. And this was one of the problems that we had, of course, low standards, not just to developing algorithms, but standards to certificate them. So I decided that we are going also to speak with John Norrish in the UW because it's interesting. So thank you so much for the presentation.
Okay, I'm glad that you liked. I was one of these people who like jumped in, and I didn't realize that what I was doing until I had that issue with the algorithm that the quality really dropped, and that's why. And then,
Yeah, the Taiwan stuff is incredible, right?
But I think it has to do with the keep learning thing, because if we try just don't hit the brakes and try to think about what we're doing, we will happen to fall in one of these pitfalls.
And one thing, Professor, how do you see the role of a domain expert? Like when we talk about ML or AI, that is just an engineer. But if that person is also expert in a particular domain or teamed with a domain expert, then these biases can be reduced to a certain extent or a greater extent, I think. Because they would know more about the data and
This is the point.
I think it really depends on the problem, I guess. Yeah, because basically, when you are saying, what do you think about this topic, Grace said on, and we all biased. Like, because we have to rely on people to people label the data, which is going to be fed to the model. So it really depends on the problem, I
I think
guess.
the secret is to have lots of people, because I can
Yeah.
only see
Yeah.
here,
Yeah,
but someone
yeah.
standing here can see here.
Yeah.
I think if I can say that today is very simple. It's for baby developer machine learning algorithms. It's not complicated. Come on. Also, my monkey brother can do it, of course, definitely.
Few lines
But
of code.
but it's really simple. You have not to be an expert of computer science to do it. I mean, to develop for your application, also deploy it is very simple. I'm not a computer science or something like that. I'm a mechanical engineer. But maybe I feel, is in my opinion, that to the knowledge of the expert, it's very, very important. It's the more important aspect to the algorithm itself.
Technical.
Yeah, because algorithm is just optimization, mathematical stuff, but it's the expert that have to label data, see the raw data, look to outliers before that the algorithm told you.
And get to working with people from social sciences as well.
Mm.
I've been trying to publish a paper about metrics of women in engineering, and my paper was just bouncing back every time. And someone said, "Oh, get someone from social sciences to help you." The lady comes in, it's the same results, but now it has a totally different point of view, and theoretical base. It's now like a more robust system. So just having someone with different set of eyes look at the data, she made wonders with my work. Something we should all aspire as well to build these teams. So WREN is a great networking platform. We should all join.
Although we are all engineers.
Yeah.
Yeah. Thank you. Yeah, now yes.
Thank you. Thank you very much.
Thank you. Thank you.